Awesome. Thank you, Alex. So great to be here, helping celebrate the Clojure 10th anniversary. So this talk is a little bit about what we've been up to in 2017, and kind of what are the puzzles that we had to solve in order to allow you to solve the problems. I think that's how Rich put it. So my name is António. I'm a software engineer at a small company in California, helping people get covered for life insurance. I have also been doing quite a bit of work in ClojureScript in the past couple of years. And I'm the author of a project called Lumo, which is a new ClojureScript environment for Node.js, entirely self-hosted. So before we get started, I think it's important to kind of clarify why we are doing this at all. Like, what is the grand vision, the bigger picture for ClojureScript? And it has always been about reach, right? Clojure is a really cool language, but there are platforms that it cannot reach. There are places where the JVM cannot go. And so ClojureScript has always been about using an arguably better, more powerful language to program the web and other platforms where JVM can't go. And I think we're really ahead of mainstream tooling in the JavaScript ecosystem, and I'll tell you a little bit more about that. So before we start, a couple things. This talk is about is as of ClojureScript 1.9.946, which was just released last week. And when I mention Clojure, or Google Clojure or Clojure compiler, it's an unfortunate name. But I'm referring to the Google project, which is a JavaScript compiler and optimizer. And I'll mention Clojure, the language, if I need to speak about it. So this talk about 2017, but we cannot do that without starting a little bit, like a couple of years back. So let's start in 2015 and prepare the stage for the kind of the big changes that we did this year. And so in JavaScript, in 2015, something very important happened. There was a very successful Google Summer of Code project where Maria Geller worked on landing initial JavaScript module support into the ClojureScript compiler. And so this is about having Google Clojure understand what foreign JavaScript you're consuming. To make this a little bit clear, like if you have a ClojureScript project, the ClojureScript compiler will compile your ClojureScript into something like what's shown there. At the top of your file, there are these goog.provide and goog.require statements, which are really a exquisite module format that the Google Clojure library understands and feeds into the Google Clojure compiler to optimize your code. But in the wild, right, JavaScript modules may be common.js, which export a function like there at the bottom. They may be the new ECMAScript 6 or ECMAScript 2017, which is now ever evolving. They may also be what they call asynchronous module definition, or AMD. And so with all these kinds of module formats, the solution that was put into ClojureScript in 2015 is about converting all these types of modules to the Clojure library format in a way that the Clojure compiler can understand them. And so what this allows is your foreign dependencies, because we're in our own ClojureScript island, and we want to sometimes, we have the need to go outside and consume some foreign JavaScript. And before this, what we did was just prepend these foreign JavaScript sources to our ClojureScript sources, or the generated JavaScript sources. And with this support, there is now the possibility, or there has been for some time, the possibility to convert these to a format that Google Clojure understands, and have Google Clojure compiler perform advanced and sophisticated optimizations on these foreign, or put it another way, these libraries are not foreign anymore. 2015 was also a year where we landed initial code splitting support. And so code splitting is very hyped right now in the JavaScript community. It is basically about shipping less JavaScript to your clients to the browser. This is very important if you need to support low-end devices or slow networks. And the Google Clojure compiler has had support for code splitting for a while now. And in 2015, David worked on adding initial support for this in the ClojureScript compiler. I'll tell you later that this year we really revamped this code splitting support in a way that is much easier to use. And so this is all very fascinating for me on a personal note, but 2015 was also the year where we landed the self-hosted compiler, or rather David did. And self-hosting ClojureScript, bootstrapping the compiler is not really about being cool, not about scoring cool points or anything. It's really necessary because there are in some cases we want to compile ClojureScript where JVM really cannot go, and it's really cool to have something self-hosted, but there was really a necessity in there. And so this is what allowed Lumo, for example, to exist, or Plonk by Mike Fikes, which has been a great inspiration for my own project. So a year later, we kept working on all the stuff that I mentioned until continuously fixing bugs that we introduced. And one cool thing that I want to highlight about 2016 is something that we call Clojure to ClojureScript namespace aliasing. And so before you had, because there are some, so in some cases, or the majority of cases, we always try to kind of mimic Clojure in the namespace names that we have. So there is Clojure.string and Clojure.set in ClojureScript. But in some cases, and because in ClojureScript macros are written in Clojure, we needed to reach for namespaces of the kind CLJS dot, because otherwise the namespace would be taken, right? If we want to write our own Clojure.test, there's already the possibility that Clojure.test from Clojure will be in the class path. So there's a namespace collision there, which prompted us to have to call it cljs.test or cljs.spec, cljs.core.async. And so in 2016, we added support for kind of automatic aliasing of Clojure to CLJS. And so you may now require Clojure.test, and the ClojureScript compiler will know that you're in reality requiring CLJS.test, and it aliases that namespace automatically for you. This is really cool with yet another feature that we also added support for, which is implicit macro inference and loading. And so before in ClojureScript, there was the necessity to sometimes use refer macros or include macros. This is no longer the case because as of last year, we can now infer that a namespace has macros and load them automatically for you. And so if you see there at the bottom, when we put it all together, and if you're writing a CLJC file, you don't need to write reader conditionals anymore in your namespace declaration, and that is really cool. And so 2016 was the year where we did even more enhancements. And so require, refer, Clojure, import can now be optionally left out of the NS form in a way that you either have an S form or some require import statements. And this was something that was not previously possible because of the way that the Clojure compiler expects to know about your dependencies. It all needs to be very static. And so this is what allows scripting, for example, in an automatically inferred CLJS.user namespace. It allows for extensible data reader support, which was not previously in ClojureScript. And once we added that feature, adding data readers in ClojureScript was trivial. With it, we also deleted a bunch of ugly, useless REPL code. There was a major hack just to make requires that the REPL work, and so we added first-class support for require out of the NS form, so REPLs just work automatically, and that was pretty cool. So, which leads us to 2017. And this has been really an exciting year. This is the GitHub contributions graph for the ClojureScript compiler project. So you can see that there are 3 activity spikes in this graph, and the first one is the initial release in 2011. The second one is when David put together self-host, the Bootstrap compiler, and the third kind of spike with the most activity is just this summer, when we added node modules and enhanced code splitting support. And I mean, this is really exciting. And we added a bunch of features this summer, and for every feature that we add, we try to really replicate it in the self-hosted compiler, so they're always at feature parity. We also got ClojureScript running on CI now, which was something that took 6 years, but I mean, it's there now. It runs on both Windows and Linux, and if you're wondering, yes, I did choose a screenshot that makes this look good. All the ticks are green there. So you know, it's been really useful to catch some mistakes and oversights. And so let's dig into a little more, and I really want to speak about the code splitting support that we revamped this year. And so as I said, code splitting is really extensively discussed nowadays in the world of browser applications. And it's a way to basically improve parse, compile, render, what they call time to interactive times in applications that need to run on slow networks and low-end devices. And Peter Shook gave a great talk about some ClojureScript topics last year at this year at Clojure West. And one of the topics in his talk was demonstrating how to code split a ClojureScript application, which was a little bit complex at the time, just like we'll see in a little bit. And he even put together his own library for helping people do that. So we went ahead and we made that part of his talk completely obsolete by changing how code splitting works in the ClojureScript compiler. But it's for the better, and so we'll see about that in a little bit. So the difficulty related to code splitting before was really, I mean, it made a lot of people afraid of touching it, myself included. I never touched it before because it was just a dragon I didn't want to slay. And so the difficulty with it, and so this is the previous way, the way that it worked previously. You had to manually assign namespaces that you want to become part of your, I'm going to call it chunks instead of modules, not to confuse with JavaScript modules that I'm going to speak about later. And so even if you did all this correctly, it was still very hard to guess the correct split points. And then in most cases, you'd still have to inspect the resulting JavaScript chunks, verify that the splits were good. It was too cumbersome. And you'd still run the huge risk of having everything end up in the what we call the CLJS base module, which is the common module that always generates some of the core library things and the core runtime. And so this is how module loading or chunk loading worked before. You had to manually assign a map of IDs to URLs, kind of have put your own module information together, and assemble a module manager that loaded your module, call a bunch of exotic functions inside the Google Clojure library. And I'm not generally in favor of showing things or showing the wrong way of doing things, but I think in this case it helps to visualize how radically different we made this module support. Also, you can't really do it this way anymore, so it's just useless. So we really enhanced the way that code splitting and chunk loading works in ClojureScript, as I mentioned. But I really wanted to show this slide because ClojureScript now has a blog. And so thanks to Alex Miller for setting it up for us. And we now write about it on every release and every major change that we add to the compiler. And so David wrote about enhanced code splitting and loading, and this is what and this is the new way of doing things. So you no longer have to assign particular namespaces or a list of namespaces to your chunks. You just add your entry point. Really the the namespace where you think you'll so let's talk about a concrete example, right? So you have a public page and a private page, right? Your landing page. You don't need to be shipping code that is only for your private, for the users that are logged in your website. If you're just showing a landing page, right? You can just load that lazily later if, say, a user registers to your website, right? And so you just need to put the entry points in there, and the assignments are automatically calculated. And it also, by having first-class support, right, for a kind of a module graph inside the ClojureScript compiler, it enables a bunch of other cool optimizations and tricks, such as splitting a vendor bundle entirely. So in this case, they say we are using a popular front-end framework and for ClojureScript, and we put that as the entry point for our vendor module. And so if that framework happens to use React or React DOM, all those namespaces will get automatically pulled into the vendor bundle, which is now separate from the rest and common from the rest of your other code, and it prevents it to be put into the base module. Even another one that David told me about, which is really, really cool. Notice that at the bottom of this slide, there's a common chunk which has no entries at all. And what this allows, or if you have a common chunk with no entries, and you have a bunch of other chunks depend on this kind of orphan chunk, what this will do is it will pull common code upper in the dependency graph, right? And you let ClojureScript do all the work for you. And in this case, the common code between the home page and the about page, and only that common code will be put into what I call the common chunk. And this was kind of mind-blowing for me. I find it really cool. So enhanced code splitting is, or module loading is also enhanced for greatly enhanced. And this is how easy it is compared to the other two code slides I showed before. This is how easy it is to wire up code splitting and module loading in the ClojureScript app today. Because we have all the information about the modules, the chunks in your compiler options, the ClojureScript compiler can just already knows what module information you have, and so you don't need to write it down in two places. So we now provide a cljs.loader namespace, which you can use to load some chunks. And we also added a CLJS core resolve macro that I want to kind of detail here. So we need to use this resolve macro when loading a chunk, because otherwise, if we were requiring, in this case it is myproject.about page, if we were requiring that namespace, right, in our namespace declaration, it would end up as part of the current chunk. It would not get split in the current chunk because we would be depending directly on it. So resolve is kind of a runtime resolve that allows you to resolve the var that you're trying to call. So in this case, we call a load about page, and this keyword is the exact needs to be the exact same ID as the chunk ID that I declared in my compiler options. And so I pass because this is asynchronous, I pass a callback to load and say, when you're done loading this chunk, please resolve my render function and call it. And so I think this is really cool and much better than what we had before. If you want to read more about code splitting in the Google Clojure compiler, I recommend this book. It is a little, I think it is from 2011. But that's as far as code splitting and module loading goes in the Google Clojure compiler. And so it's still up to date with regards to that, because support existed back then. Which leads us to the next topic of this talk. So let's talk about the JavaScript ecosystem. Woo! So currently in the world there are a lot of JavaScript developers, and we don't want to be isolated in our own lonely ClojureScript island. In some cases we want, and in other cases we really need to interact with JavaScript library frameworks. And so this year we really built on the support that Maria added in 2015, the JavaScript module support, and we delivered on the promise of making this much easier and to consume. So thanks to her work, thanks to further enhancements in the Google Clojure compiler, we now have the ability to just take arbitrary NPM modules from a node modules installation, run them through the Google Clojure compiler, and use them seamlessly in our ClojureScript projects as if they were regular ClojureScript namespaces. And we'll see an example of this later. And these JavaScript dependencies are really not foreign anymore to the ClojureScript compiler, because Google Clojure now understands them, and we'll see how we can even refer them in our namespace declaration. So the way we did things before with these dependencies was just to bundle everything together, consume them through a foreign libs entry in the compiler options. Just in CLJS.js, which is a project that aggregates a bunch of popular JavaScript libraries, does it this way, right? It exports, or it gives you a bunch of jars that that give you foreign dependencies packaged together in a way that Google Clojure does not understand. So what do we need in ClojureScript, or what did we need for a modern interop story, and what did we need to put there in the compiler so that you can take advantage of that today? And so I really want to go through how do we consume NPM modules in a way that Google Clojure understands in order to perform sophisticated optimizations. How do I integrate JavaScript sources in a ClojureScript project, even including JSX, which is a popular way of writing kind of HTML in your JavaScript that transforms to React virtual DOM elements. And this was a concrete example that we heard at EuroClojure 2016. We talked to a company in which their designers, they were really familiar with using React and JavaScript and JSX, but they couldn't get into kind of hiccup syntax for ClojureScript, such projects such as Sablono and Reagent that allow you to write kind of these React virtual DOM elements as vectors of keywords, so just using plain ClojureScript data structures. And so their designers couldn't get into that. So they were asking for an option of integrating that directly in their ClojureScript namespaces, because the way they were doing it was just bundling everything together and consuming a foreign dependency of their own code, which shouldn't be foreign. So how do we consume NPM modules today? Well, you add an npm deps entry to your compiler options. In this case, I'm saying my project depends on React and React DOM. And notice how we can just require React and React DOM and alias or refer these modules as if they were. So we're really treating NPM modules as if they were regular ClojureScript namespaces, because it just works. Google Clojure is now aware of it. We also allowed support for a couple different module import patterns. So when you're requiring JavaScript modules, sometimes you need to reach them through a path, which can contain several slashes, and those are not valid symbols in Clojure. So we relax the constraint that require only take symbols in order to make these requires with arbitrarily nested forward slashes work in your namespace declaration, and they work just like you'd expect them to work. We also added the ability to resolve required modules as variables, and this might seem kind of weird, but it's a necessary evil that is required because there's a module export pattern. So normally, if you have a JavaScript module, you can export a JavaScript object, and we can understand that just fine. You can alias that. You can refer to modules in that to functions and variables in that namespace as if they were ClojureScript namespace. But in some cases, modules decide to export a single function, and we had no way to reach for that without making a resolve work with the namespace that you're importing. So how do we integrate with JavaScript sources, right? We know how to require modules in our ClojureScript namespaces. So how do we require JavaScript sources that may or may not be in our project? So the way you do it is through the old foreign leaf style. We know about this. So in this case, we added support that you can now pass a directory to a foreign leaves entry, and say this directory provides this namespace, and you can require that, and we will kind of track what JavaScript modules that directory or the modules in that directory require. We will go pass them through Google Clojure, and everything would work like just like I've been showing. Yet another cool thing is Babel and other JavaScript compilers are very popular today in the JavaScript ecosystem. So in your foreign leaves entry, you can now add a preprocess keyword that refers to a symbol that will resolve at runtime. And so with this, you can declare a namespace which has, say, transforming functions that will take preprocessed, that will take raw, JavaScript or JSX or anything that Google Clojure doesn't understand. It's up to you, like calling to Nashorn or call shell out to Node.js to transform those, say, using Babel, and transform them to JavaScript that the Google Clojure compiler can understand. And I'm really, really pleased to say that we're trying to do this with the least amount of breakage possible. And so this might be kind of weird to explain, but if you bundle everything together in a single bundle, we used to do before, say you have a React and React DOM huge bundle run through Browserify or Webpack that provides a React global variable, but now you want to migrate to the new module support. We provide you a migration path through a keyword called global exports. So you can say, so here's my my React bundle, and it has the React with capital R global variable. And so we tell the ClojureScript compiler, please be aware that this global variable really is, like when I'm requiring the React or CLJS, JS, React namespace, this is really referring to that global variable that we have. And so in this case, aliasing and refers work as if they were an NPM module. And I'm really excited about this because this will allow library authors to provide a clear migration path from the current way of doing things to module support in a way that is seamless for application developers to upgrade. So kind of circling back a little bit, what can ClojureScript do for you in 2017? How can you take advantage of ClojureScript today in order to build your applications? And my stance is that I think we have, if not everything, at least almost everything that we need. So we can require ClojureScript dependencies, just like we did. We can reach to the wider JavaScript ecosystem, integrate with popular package managers such as NPM, Yarn. We're no longer stuck in our own island. We have code splitting through Google Clojure with first-class support for chunks. And this is really important. If we compare to mainstream tooling in the JavaScript ecosystem, in which you kind of define your split points inside your own code through magical import statements, in the ClojureScript world, we have the ability of defining first-class chunks through our compiler options that are really that you can then load at runtime. You can explicitly load a chunk instead of putting a magical keyword or comment in your code. So Google Clojure is a very sophisticated project that also provides you what they call cross-module code motion. And what this is if your namespace happens to be part of a chunk, but you're using a single function from that namespace in another one, Google Clojure knows how to move that single function from the first chunk and all its dependencies to the second chunk in a way that, so both modules, or put it a better way, it provides better locality for your code. So we can target the web, we can target Node.js, we can target platforms such as React Native. I think the self-hosted compiler can even go further. So I'm really looking forward to the day where ClojureScript can go to outer space. Because if they're using Node.js for the NASA spacesuits, I think ClojureScript can one day be up there too. Thank you. Do we have time for questions? Does anybody have any question? There's no story about publishing to NPM. If you're developing ClojureScript, I don't think it's particularly useful to ship your ClojureScript code to NPM. This might change one day with things like Lumo, and I'm actually exploring that possibility myself because now we have something that can have first-class support to reach for ClojureScript code in node modules, but nothing exists like that today. Yeah. Uh-huh. So the question was, he's done a little bit of React Native development, and he was saying that the React Native packager is a little bit weird in a way that it runs after the ClojureScript compilation process, and if there was another way of hooking into that process. Is that a question? Hooking into that process in a way that doesn't mess with the React Native packager that provides a better support. Nothing that I'm aware. I'm not very familiar with the React Native ecosystem. I know there is an alternative project to the packager which runs with Webpack. I think in that way you could, I mean, you'd still have to run the ClojureScript process, but then you could bypass the packager and run your code and bundle it through Webpack and serve it to your mobile simulator. Yeah. That's a great question. I also didn't talk about extern inference, which is something that was added in 2016. So you can now add a, I'll answer it. So the question was, does this solve the externs problem? In most cases, it does. But we have no control over what JavaScript libraries do. And in some cases, they use very dynamic code and generate functions and variables at runtime. There's no way for Google Clojure compiler, which is a Java project that performs static analysis on JavaScript, to know that you're generating those variables at runtime. So externs might still be needed in some cases. And kind of circling back to externs inference, you can now add kind of type hints like you do in Clojure to your ClojureScript code and have the compiler generate externs automatically for you. I think there's also a blog post about that. Yes? The question was, I've got a JavaScript module and I process it through Clojure, required my ClojureScript namespace. Does it get sent to the Google Clojure compiler for advanced optimizations? Yes, that's exactly what we gain. We now have the ability for Google Clojure to understand our code and perform sophisticated optimizations and that code elimination on JavaScript sources that were previously foreign. Yeah. Yeah, the NPM support is about consuming, not publishing. Yeah, well, just so I can install my ClojureScript, command my app into the system to the NPM install. So compatibility with the package method in NPM format is from the install. I can't hear you very well. We can speak about that later. Awesome, thanks.